TII's Quantum Research Center is one of the research centers of the Technology Innovation Institute in quantum technologies, and it's a hub for quantum technology innovation. We see the Quantum Research Center as playing a key role towards hosting the future capabilities of quantum technologies for the entire country. We want to produce technologies, we want to host technologies and do research, and also we want to nurture the local talent for the future. We do applied research, and it's structured into 6 different research efforts distributed across 3 main quantum technologies: quantum computing, quantum sensing, and quantum communications. We pursue a balance of science, technology development, as well as industrialization and commercial agreements. That's the way we tackle the whole spectrum of activities, and we guarantee the relevance of the country as a key player in quantum technologies in the world.
TII's approach integrates hardware, software, control electronics, and the infrastructure to build a robust quantum computing ecosystem capable of tackling the challenges of the field. Superconducting circuits are very special electric circuits that, when we put them at extremely cold temperatures, we can exploit the quantumness that emerge in their dynamics. 4 years ago, TII looked at what were the front runners for quantum computing and decided to choose this platform in order to pursue this task. Refining the superconducting qubits is a very, very daunting task. Our approach is we look what people have done, what they have proposed, and we hope that we can improve our device by being smart enough to learn from others' approach and propose our own solutions.
Quantum algorithms will enable to solve problems of commercial and industry relevance that are intractable today, like, for instance, simulating complex molecules whose computational simulation is now too expensive. Part of the software that we do is called quantum-inspired algorithms. These are algorithms that take inspiration or techniques that have been discovered in the mathematical study of quantum computing theory, but that can be deployed nowadays on a classical machine. We do research, for instance, protein design. This is relevant for drug discovery and drug synthesis. And then there's, of course, the software that controls the quantum hardware. There you really need compilers that can connect the abstract ideas of quantum algorithms with the radio frequency pulses that run a superconducting qubit devices or the optical systems that control trapped ions. We tackle the full stack in the Quantum Research Center.
Quantum sensors are mostly based on so-called qubits, quantum mechanical bits, and they are really that sensitive and accurate because they are as simple as you can build a system. They are connected to fundamental principles of our physical world, and this makes them very drift-free. The sensors which we are building here, one is the so-called inertial sensor. There we measure accelerations, and if you measure acceleration and time at the same time, then you can calculate the position. So this of course helps you now to position yourself even without GPS. And additionally, we work on a different class of sensors which are called quantum magnetic field sensors, which are very sensitive to magnetic fields. And you can use them for quite a wide area of applications. One, for instance, is medical imaging, where you would measure the magnetic field of your body. Similarly, you can sense currents in the ground, for instance, to do subsurface imaging, or they can be used for positioning and navigation.
Quantum key distribution is a family of protocols for generating provably unbreakable encryption keys, where the security of these keys relies not on assumptions about the complexity of calculations or on your adversary's computation ability, but on quantum physics. At the Quantum Research Center at TII, our teams are building 2 types of quantum key distribution, one based on quantum entanglement and one which is a cost-optimized solution that we call our last mark UKD system. The hope is that we will be able to use the entanglement-based system to build metropolitan networks, and then once these networks are in place, we'll be able to use our cost-optimized solution to connect end users to such networks. In 2024, my team built and opened the Abu Dhabi Quantum Optical Ground Station. This is a facility located in Al Wathba, and this is a purpose-built facility for tracking and building optical connections to orbiting quantum satellites. The facility is optimized for performing quantum key distribution, so it will act as a node in a global quantum network once the satellite infrastructure is in place.
If we really see the Quantum Research Center and TII in general as a long-term project, we really need to fixate international talent into the country as well as to nurture next generation of local scientists.
We organize joint workshops and conference, training schools together with the local universities. And we also try to cooperate with them to shape teaching programs in quantum science and technology. Besides that, we have many projects with industries, try to solve practical issues that the industry have and that quantum can help. We use our network to make meaningful relations with the well-known global research institutions and also startups and other entities at the level of national labs. We need a balance between basic science and applied science, and this aspect is particularly important.
The Technology Innovation Institute is laying the basis for a new era of quantum innovation by tackling the full stack range of activities of the most promising quantum technologies. We really want to deliver solutions to industry problems in the near term, as well as to find out and spin off different innovations and discoveries that may have impact in the future.
TII has been doing a great job to bring people and to build an infrastructure that few places around the world have. We have the opportunity to exploit all the knowledge available and integrate everything in a single place.
So what we have to do here to stay at the forefront is to really focus on people. So this is really talent, attraction, keeping the talent.
We really need to think of this institute as the future host of the country's capabilities in terms of quantum technologies.